So rational expressions can now become rational equations, and we know everything we need to know to work with these. For example, 2x over x plus 1 is a rational expression, and if I add that to x minus 3 over 2x plus 5, I now have a rational equation, and I can solve for x. I'm not going to do it in this one because I just made that up off the top of my head, and whenever I do that, trying to solve that work becomes a crazy mess. So I'm going to do this with a much nicer equation, pre-tested with a pretty solution taken straight out of the book. So x, or 8 over x plus 6 equals x over 2. Now, there are a number of different ways to go about solving rational equations. Different people do it in different ways. They're all fundamentally the same. I'm going to show you mine. I like to pretend that the equal sign is no different than a plus sign or a minus sign when we're adding and subtracting. So I'm going to take this right through the lowest common denominator algorithm. So this is already factored. X plus 6 is just one number, and 2 is obviously just one number. So the lowest common denominator in this case is x plus 6 times 2. So using my lowest common denominator algorithm, I can say that 8 over the lowest common denominator is the same thing as 8 times 2. I have to multiply that 2 in because it already had an x plus 6 in the denominator. To make it the lowest common denominator, which I'm going to say LCD from here on out, to make it the LCD, I had to multiply it by 2. If I multiply the denominator by 2, I have to also multiply the numerator by 2. Same thing on the other side. I have an x. If I'm going to put the x over the LCD, that means I had to multiply 2 by x plus 6 to get the LCD in the denominator, so I have to multiply that same x plus 6 into the numerator. Now, what I have is, notice, I have the LCD on both sides of the equal sign. So there's a little trick to this. If I want to get rid of this LCD, I can multiply LCD into the numerator on this side so that these cancel. If I do it to the right-hand side of the equation, I have to also do it to the left-hand side of the equation, but that's automatically going to cancel the LCD on the other side. And so the shortcut is, when there is an equal sign, only when there's an equal sign, if there's an equal sign separating two lowest common denominators, I can just cross them out. So now I'm left with 16 equals x squared plus 6, x squared plus, 6x, x squared plus 6x, take away the 16 from the left-hand side, that whole thing now equals 0. Because when I subtracted 16 from this side, it became 0. Now, factor. Two numbers that multiply to give me 16, but add to give me 6. That's going to be an 8 and a 2, I'm pretty sure. It has to be, one has to be negative, but to get a positive 6, plus 8 minus 2 equals positive 6, and that's a 0. So x plus 8 equals 0. X minus 2 equals 0. X equals negative 8, and x equals 2. Now, I know you're going to hate this, but you have to do it all the time. Notice, and this is why, notice that when I was solving the equation, I didn't put my Mayday, Will Robinson, x plus 6 can't be 0, and 2, right? I didn't caution myself from an excluded value. And the reason is, when I'm dealing with equations, I go ahead and solve like there are no excluded values, and then I plug them in to check. So I have 8 over, check the negative 8 first, negative 8 plus 6 equals, I can do this, negative 8, I got a little lost, sorry, over 2. And so I'm checking to see if that's a true statement. I'm just checking my solution. So I have 8 over negative 2 equals negative 8 over 2. I can keep going. I don't really need to because it's clearly -4 equals -4. But at this stage, I could have said, yeah, that's clearly an answer. So that's okay. Now let's do it with 2. 8 over 2 plus 6 equals 2 over 2. So 8, and this is a question mark, I'm not really sure, 8 over 8 equals 2 over 2. Well, that's just 1 equals 1. And so that is also a solution. So I've checked to see that these are truly the solutions, and they are, so I'm good to go. You have to check, because sometimes you'll get an answer that's perfectly fine in the whole quadratic that you've solved, but it's not fine in the original problem. So you have to check these answers. If you get an answer that doesn't work, it's called an extraneous solution. Let's do another one. So I have 2x over x plus 3 plus 1/3 equals -6 over x plus 3. So notice this time I have 3 rational expressions. I have a plus sign between 2 of them, and I have an equal sign between the other 2. I can just treat these like I did any others. Don't worry that one's an equal sign and one's a plus sign. Just find a common denominator. In fact, there are 2 really distinct ways to handle this. Since I have a common denominator, or excuse me, the denominator on this side is common to this side, I could subtract this over and create one function, and then I get something that looks just like this, or one fraction. Does that make sense? Let me do it. Let me show you. I don't know if I'm going to go all the way with this one, but let me show it to you. I could take the 2x over x plus 3 and subtract it from the other side. So on the left-hand side, I'd have 1/3, and on the right-hand side, I'd have -6 over x plus 3 minus 2x over x plus 3. All I have here is the same denominator, which means I can just do that and and then I have 1/3 equals -6 minus 2x over x plus 3. So 1/3 equals -6 minus 2x over x plus 3. And then if I do the lowest common denominator and finish out, I'll be able to cancel those out. Totally allowed if you see that pattern. If you don't, though, and just in case you don't always see a pattern, let's just do this the old-fashioned way. I have 3 fractions, and I need a lowest common denominator. So this fraction is totally factored, this fraction is totally factored, and this fraction is totally factored. Okay, what I said isn't exactly true. The denominators of each fraction are totally factored. So the lowest common denominator, start with the first fraction. I need all the factors that are in it. X plus 3, that's all the factors. Move to the next one. I need a 3. Oh, I don't have a 3, so I need to put in a 3. Move to the next one. I need an x plus 3. Oh, look, I already have one. I'm done. Right? I don't have to duplicate. Okay, so now I have 2x over the lowest common denominator, which means I already had x plus 3. I need to multiply a 3 into it. Plus 1 over the lowest common denominator, which was a 3, which means I multiplied x plus 3 into the denominator. I have to also multiply x plus 3 into the numerator, equals -6 over the lowest common denominator. I already had an x plus 3. I need to multiply a 3 in. Now look at this. I have lowest common denominators straight across. Doop. Done. And the reason I can do that is because I have an equal sign. If I have an equal sign and all the same thing in the denominator, I can just take them right off. That's pretty cool if you ask me. Okay, so let's finish this up. 2x times 3 is 6x, plus 1 times x plus 3 is just x plus 3, equals -6 times 3 is -18. So 6x plus x, 7x, plus 3 equals -18. 7x equals 18, 19, 20, 21, -21, and x equals -3. So I only got one answer out of this one instead of 2. So one solution. I still have to check it. Now this one I'm not going to check by plugging it into the original because it is obvious that x equals -3 is never going to be allowed, because if I put in -3 plus 3, I'm going to get 0 for 2 of my denominators. That means, check it out, there are no solutions. So there's no solutions for this problem. No values of x for which I can solve this equation. That's kind of like what I expected to get up here. When I just made this up, I probably would have ended up with a problem with no solution. So there you go. So let's do one more example, this one with a quadratic in it, because you haven't had a good time until you've done a quadratic. X minus 1 plus 1 equals negative 10 over x squared minus 9x plus 8. Okay, first things first, we have to factor all the numerators, or denominators. So 4 over x minus 1 is factored, plus 1 over 1 equals negative 10 over x, two numbers that multiply to give me a positive 8, but add to give me a negative 9. That's got to be x minus 1 and x plus, whoops, not plus, minus 8. So double check. Negative 8 times negative 1 is positive 8. Minus 8 minus 1, negative 9. Good. Now let's create our lowest common denominator. So start with the first fraction. I have a factor of x minus 1 in the denominator. Second fraction, factor of 1. I don't really have to write it down, but I'm going to just to make the point. Second, I need an x minus 1, but I already have one, so I'm not going to write it down again. X minus 8, x minus 8. So this is my lowest common denominator. Now I'm going to write my fractions over. So 4 was divided by x minus 1. In order to write it, in order to make the denominator the LCD, I had to take x minus 1, multiply it by 1, and multiply it by x minus 8. So that's 4 times 1 times x minus 8. Plus 1 over, well, the only factor originally was 1. I have to multiply x minus 1 and x minus 8. Over the lowest common denominator. That was the whole point. And then negative 10, well, negative 10 has the x minus 1 and the x minus 8 already, so I have to multiply it by 1. Obviously, you don't have to write that down. I'm just kind of trying to keep it neat and tidy for the lesson, but you don't have to write that down. So now, I have an equal sign, and I have the same denominator everywhere. Just cross it out. Only if there's an equal sign, though. Not if there's only a plus sign. If there's an equal sign, and I have the same denominator everywhere, I can cross it out. So now let's do some distributions and figure out where we are. I have 4x minus 32 plus x squared minus 8x minus x plus 8 equals negative 10. Let's combine everything. I'm going to use cross out. So I have 1x squared. Then I have 4x, take away 8x is negative 4x, take away another x, negative 5x. Negative 32 plus 8, negative 24 equals negative 10. All right, so finally 8 or x squared minus 5x, negative 24 plus 10 is negative 14 equals 0. And so x, I'm just going to factor two numbers that multiply to give you 14 but add or combine to give you 5 would be a 7 and a 2. And 1 has to be negative. It would have to be the 7 in order for the 5 to be negative. And so I get x equals 7 and x equals negative 2. 7 and negative 2. Now let's look up here and see, are these going to be a problem? So we're not really worried about the numerators, but we're worried about the denominators. Is 7 going to make any denominator equal to 0? It is not. 7 minus 8 is negative 1. 7 minus 1, positive 6. 7 minus 1, positive 6. How about negative 2? Negative 2, take away 3. excuse me, -2 take away 1, -3, totally okay. Same thing here. -2 take away 8, -10. None of those are zeros, and so all of these solutions are correct.